Thank you everyone for joining us today for the Alzheimer's Disease Research Center's Alone at Home series. Today we have Mark Bernard here with us. Dr. Bernard is a research assistant professor of neurology at NYU Grossman School of Medicine, where he's a junior research faculty at the ADRC, and he's also part of our biomarker core. His current research focuses on increased understanding and development of biomarkers of Alzheimer's disease, particularly those in blood plasma. He investigates associations between neuropsychiatric symptoms and changes in these biomarkers, and is further interested in the nexus between plasma, AD biomarkers, and sleep and circadian rhythm dysfunction. And with that said, I'll turn it over to Dr. Bernard.
Thanks so much, Abena, and good afternoon to everybody who's joined us for our Learn at Home series. Really excited to be here and to tell you a little bit about what I do and some of our recent work in this area. And one part Abena didn't mention in my introduction, I'm a diehard Knicks fan, so Knicks in 7 for those of you on the line who are watching the NBA playoffs right now. So just a little flavor, a little bit more by way of introduction about me. This is me, much younger, and just having earned my PhD. I'm a proud NYU product, a proud New York product. That was some time ago. I earned my PhD, but what you might not know, and what Abena didn't mention in her introduction, is that my PhD is actually in chemistry. So I come from the lab. I've worked with a lot of small molecules, produced a lot of small molecule inhibitors. Um, and a lot of things that bind to neurotransmitters. So I'm very interested in the molecular basis of medicine and disease. Um, Being the crazy person that I am and with my thirst for knowledge, after my PhD was done, I went back to school again. And I did a fellowship in clinical epidemiology, and I earned a second master's and embarked on my clinical research career. So now I've been here since 2022, back at NYU as a faculty member here in the Department of Neurology and here at ADRC. Uh, Recently promoted to assistant professor earlier this year. And as Abena mentioned, my research focuses on these blood-based biomarkers of Alzheimer's disease, which we'll talk a bit more about today. I'm also interested in Alzheimer's disease and sleep and circadian rhythm dysfunctions. And we'll also talk today about these neuropsychiatric symptoms of Alzheimer's disease, which are actually pretty common as part of the disease. And something near and dear to my heart is health disparities work. Um, Not everybody reaps the same benefits from research in Alzheimer's disease and in this dementia field. Um, and that's something I hope to take part in changing. So my talk today, as we've mentioned, is blood-based biomarkers and neuropsychiatric symptoms in Alzheimer's disease. And what you can expect is kind of three main parts. There'll be a part about blood-based biomarkers. There'll be a part about neuropsychiatric symptoms and one neuropsychiatric symptom in particular, which I'm very interested in. But first, let's talk about, in broad overview, Alzheimer's disease and why these blood-based biomarkers and neuropsychiatric symptoms matter to Alzheimer's disease. So here's a cartoon of the human body. When we think of Alzheimer's disease, we think of, I know how it was for my family growing up. I've had some older relatives with dementia, someone who just passed away a couple of months ago. When we think of Alzheimer's disease, we think loss of memory. We think forgetting things. We think of it as a disease of the brain, which, to be clear, it is. However, the brain affects so many other things in our bodies. There's so much else that is controlled by the brain and affected by the brain and modulated by the brain. So Alzheimer's disease is not just about the brain, but about many other places in the body. One of the symptoms of Alzheimer's disease is there are sensory symptoms, changes in smell or hearing or vision. Um, there are also characteristic in Alzheimer's disease and in dementia are changes in cardiovascular function. This can affect your gut health and your microbiome. And in fact, some therapeutics are even affected by your meal times. Alzheimer's disease and related dementias can affect gait and walking, and we have a whole research program here surrounding looking at we have a cool little walking machine that measures people's gait, their footsteps, and how that's affected as dementia progresses. This is another factor. I won't be talking about this today, unfortunately, but another part of my research that's kind of near and dear to my heart is changes in sleep and circadian rhythms that both are cause and consequence. It's not really sure. There's a bit of a chicken egg bidirectional relationship with dementia and changes in sleep and disruptions in sleep. But what we're going to focus on today, out of all of these changes to the body, is these neuropsychiatric symptoms. And when I say neuropsychiatric symptoms, think things like depression or stress or apathy. And I've got down there in the bottom in slightly larger print, that's the one neuropsychiatric symptom on which we'll focus primarily today is anxiety. And as we'll see later in the talk, we've done some recent work on anxiety that's, well, I find pretty exciting and should uh, should lead to some great questions to ask down the road. So long story short, examining Alzheimer's disease from a whole body perspective and not just thinking about the brain can provide inroads and insight into ways we might think about early detection and intervention down the road. So let's talk a little bit about the spectrum of Alzheimer's disease, just going through the whole lifetime of Alzheimer's disease, if you will. So everyone starts out kind of cognitively normal. No complaints about memory or executive function or changes that can be noticed. Um, the next stage after being normal is what we call the preclinical stage of Alzheimer's disease. And you can see over there on the right-hand side of your screen, maybe I can even highlight this a little. You can see over there that normal cognition, actually I will do this, I'll highlight that for you. We can see over here that normal cognition, we have normal cognition, but there are also bio and clinical markers, which we'll talk about a little bit later. Following the preclinical stage is what's called the prodromal stage. So cognition at this point starts to change, and there are measurable cognitive defects clinically. And one stage of one part of the prodromal stage that's common is something called mild cognitive impairment, or MCI. And we can see over there on the left that this is 12 to 15% of people over the age of 65. Following the preclinical and prodromal stages, we get into mild dementia. And we can see over there on the right, we see these ADLs or activities of daily life. So there are basic ADLs, BADLs, and also IADLs, which are important activities of daily life. So, or integral activities of daily life. And in mild dementia, uh, one might be dependent on others for these IADLs. Think of things like paying bills, or making a budget, something where you would need math skills or higher executive functioning skills. But basic ADLs, such as getting out of bed, walking to and from the bathroom, those will remain intact in mild dementia. And these are 14% of people over the age of 71. And then finally, as we progress into moderate, severe, and end stage dementia, eventually these basic ADLs, people become dependent on others for basic ADLs. And as the dementia becomes more severe, they're no longer able to function. And in the end stages, people become nonverbal and ultimately bedbound. So this is another diagram here. This is called a Jack diagram after the author who originally published it in their paper. Um, this shows going from left to right the clinical disease stage, and on the y-axis, kind of on the left, going from up to down on the left, is the changes in specific biomarkers. So there's a few curves here that we see. We see in red amyloid or amyloid beta, A beta. Blue is a tau, which is a measure of a neuronal injury and dysfunction. And then in the light green is brain structure, and purple memory changes. So memory abnormality would be greater as the curve goes up. And then clinical function or loss of clinical function. And we can see here on this diagram that as we go further, each of these things increases, starting with the amyloid the soonest. So where do we want to target? What's the importance of this kind of a progression? Well, here in the dementia stage, kind of when we started Alzheimer's research, there was always a desire for a drug or therapeutic that could reverse dementia. But by this stage, it's kind of too late. And many clinical trials have failed at this stage where somebody already has dementia and already has this high level of amyloid, tau, and changes in brain structure. By then, it's too late. In this stage, so prior to that, with lecanemab and donanemab, which are two recently approved, FDA-approved drugs for Alzheimer's, um, in this stage, we have lecanemab and donanemab that have been successful, so a little earlier in the progression. But you can still see at this point, there's still quite a bit of tau and amyloid beta dysfunction. So what we want is to focus much sooner in the disease progression. We'd like to focus here instead, prior to MCI and earlier into the preclinical stage. However, that's a major challenge because it's not always easy to detect and monitor Alzheimer's disease so early. So focus on these early stages is key. So let's talk about these biomarkers. We mentioned amyloid beta, we mentioned tau. And just broadly speaking, um, biomarkers are just any kind of objective measure of disease pathology. Um, in Alzheimer's disease, we primarily talk about amyloid beta and tau. There are many others. To use an example from the non-Alzheimer's disease world, if we think of cardiovascular health, a common biomarker is blood pressure. Now, it's just a number, but it tells you something about your cardiovascular health. Your cholesterol level, that tells you something about your cardiovascular health. So amyloid beta and tau are things that tell us about uh, our health with respect to Alzheimer's disease. Here's a cartoon of kind of what it looks like in a normal brain. You see some neurons in the brain, but with Alzheimer's, there are these other structures. There are these neurofibrillary tangles, tau tangles, and also amyloid plaques that form in the brain. And here on the right, we can see some actual pictures of these from histopathology of these tangles and plaques. So there are a few ways to observe these in patients and in humans. Through the cerebrospinal fluid, or CSF, which you obtain by lumbar puncture, which is, for those who are not familiar with lumbar puncture, it's just what it sounds like. A needle gets stuck into your back and the spinal fluid is removed. There's also neuroimaging. So PET scans, for example, are an example of neuroimaging. You can see many of these structures in these two types of analysis. And on this page, there's just here are just a few examples of the types of uh, biomarkers we'll see in both CSF and in neuroimaging. However, there are some drawbacks to these. These are reliable, and we can see these structures and learn about one's Alzheimer's disease state, but there's some drawbacks. One of which, these are expensive, especially the neuroimaging. Um, And for those of you on the call who might have fought with insurance companies, I have fought with my insurance company over some imaging I had on my shoulder not too long ago. Imaging's expensive. These are expensive kinds of treatments, kinds of measurements. And as I said, lumbar puncture is a needle in your back. That's invasive. Many of us don't like needles anyway. So to have one in your spine to take your spinal fluid is very invasive. Another thing that we think about as researchers is that when we want to have participants participate in our studies, in our clinical trials, and they hear, well, miss, we're going to take some of your spinal fluid. they're not going to participate. They're going to run. So sometimes these methods can discourage participation of people. I know my uncle, for example, hates being inside that machine. He's a larger, heavy-set man and has terrible claustrophobia. These might discourage participation. And I think the biggest challenge of these, as I mentioned a moment ago, is that as great as these techniques are, they come late in disease progression, after it might be too late to really do anything. So kind of at this point here and after in our diagram from earlier. So one solution that myself and many people in the field have been working on is what if we could see these biomarkers, this amyloid, this tau, and others, by just taking someone's blood. Now, even though that's a needle, that's much better than a needle in your back. So let's talk some about these plasma biomarkers and blood plasma, these blood-based AD plasma biomarkers. They have several advantages, one of which is they cost less. That's great for everybody. That's great for hospitals, great for clinics, great for researchers like myself, and it's great for the participants. These are more accessible and less invasive compared to those other methods. So there might be greater buying, greater participation. People might be more willing to find out, hey, what's my status of Alzheimer's? They facilitate longitudinal observations. What's that mean? That just means we can look at more time points. We can take your blood every week or every day if somebody might want to do that, and find changes in one's health more often than might be possible with these other methods. And importantly, um, we can envision a day in which, if these blood tests become clinically used, we can imagine getting a simple blood test at your annual checkup or something like that, enabling earlier evaluation in the disease progression. Many people don't know they are developing Alzheimer's disease. These tau tangles and amyloid plaques develop silently for decades before symptomatic Alzheimer's dementia begins. And just a little science nerd thing for people like myself, state-of-the-art instrumentation is now available that we can measure these biomarkers more precisely than ever in blood specifically. So let's talk about these blood-based biomarkers. So what kinds of blood-based biomarkers are there? I mentioned amyloid, I mentioned tau, and I won't bore you with all of them, but there are quite a few. There are many. There are many types of amyloid and tau that are available and that researchers like myself here at the center and others have been working on developing to ensure that we can monitor disease progression and learn more about who might be likely to develop Alzheimer's in the future, who might have it now, and possible treatments and interventions. There are different types of amyloid, amyloid beta 42 and amyloid beta 40. And what this tells us is when this ratio decreases, this tells us about cerebral amyloid deposition. And it's possible that this is prognostic, but we don't know yet. There's so much research out there that we need to do. And there are many other types. There's also many companies, many pharmaceutical companies who are actively developing types of biomarkers for testing to be used in the clinic to bring this holy grail of a blood test for biomarker to the for Alzheimer's disease to the clinic so that we can monitor people's progression. We can see from C2N, Quest, Roche, Shimadzu, big names in the field that are trying to figure out how we can get a clinically useful, clinically available blood test for Alzheimer's disease using these biomarkers. So from all of this, there's a few things that we know. I've highlighted there in the yellow box this phosphorylated tau or p-tau 181 and this p-tau 217. This one in particular has shown great promise for usage as a potential reliable clinical biomarker, blood-based biomarker for Alzheimer's disease. And we can see over there on the right under differential diagnosis, this can even potentially differentiate between Alzheimer's disease and other types of dementia. For example, FTD, frontotemporal dementia. That's a big thing because many dementias look similar, have similar structures in the brain. So something that can even differentiate Alzheimer's disease from those others is, like I said, holy grail. We would love to have that in the field. There's a few things we learn here. So p-tau, this phosphorylated tau, appears to be more sensitive and specific to Alzheimer's disease, specifically Alzheimer's disease, as opposed to other dementias. P-tau 217 appears to be better at this task compared to the closely related p-tau 181. Mass spectrometry, which is near and dear to my heart as a chemist, appears to be better than immunoassay. I don't know how many other scientists are on the call. I might get in trouble for this line because not everybody agrees. This is important too, and this is the reason why a seemingly conceptually simple problem has been difficult to solve over the years. By using this in the clinic and applying it to real people, there are so many comorbidities, so many other conditions that can affect how these blood-based biomarkers might show up in someone's test. So you don't know, is it because this person has Alzheimer's or are they diabetic or something? Separating out those comorbidities from the actual presence of disease has been a real challenge. And when widespread use is ultimately accepted for use in unimpaired patients, it's unclear how this will be, how useful these might be in cognitively normal people who are preclinical. That's not totally clear just yet. And on a practical note, insurance doesn't cover these right now. And that's, even though these are cheaper compared to the other tests, that's a big one. So you may have heard something about this in the news recently. Okay, so this is very recent. This is like in the last week or two. So the FDA has actually cleared a blood test for use. And we can see here, Lumipulse, they have a p-tau 217 amyloid beta 42 ratio for patients aged 55 and older. So this is becoming reality as we speak, very recently. Okay, so we've talked about blood-based biomarkers. Now let's talk about these neuropsychiatric symptoms of Alzheimer's disease. So what are neuropsychiatric symptoms? We talked earlier about, we mentioned depression, apathy, stress, anxiety. And many of these are part and parcel of the Alzheimer's experience. So we see here this bar graph. There are different stages of the disease listed at the bottom. Subjective cognitive decline, mild cognitive impairment, dementia, severe dementia, all the way up to what's called the GDS-7 stage, the Global Deterioration Scale. And we see the different neuropsychiatric symptoms here: psychosis, disturbance, aggression, diurnal disturbance, that's that sleep and circadian rhythm I was mentioning earlier, depression, and anxiety. So we took a look at 200 participants followed over time here in our center. And in the later stages, as we can see on the graph, there is a lot more of this activity disturbance, psychosis, and aggression. What was interesting is that in the earlier stages, as we see here in the purple boxes, anxiety was much more common earlier on. So we think perhaps that anxiety might be a prominent neuropsychiatric symptom of early stage Alzheimer's disease and potentially an inroads into designing some kind of therapeutic or intervention. So here's what we know about anxiety specifically. So keeping in mind, we're focusing on anxiety because it seems to be the most prevalent in those early stages that we wish to target. Here's what we know. And we can see some data over there on the right for preclinical AD patients. we noticed that carriage of the ApoE4 gene is associated with increased anxiety at certain stages. Now, ApoE4 is a genetic marker, and people who have the ApoE4 gene, we found over the years, over many years of research, that people who have a copy of the ApoE4 gene are have a higher prevalence of Alzheimer's disease, and those who have two copies, an even higher prevalence for Alzheimer's disease. So Alzheimer's disease is definitely associated with carriage of this ApoE4 gene, and it's also associated with increased anxiety. Anxiety has been associated with faster progression. We see down here in this bottom bar graph um, that years to progression is significantly less with anxiety. And also, treated anxiety is associated with slower progression. However, there is a lot we still don't know about not just anxiety, but all neuropsychiatric symptoms, anxiety specifically. There's a lot we still don't know. So this is a cartoon or a diagram from a recent paper by my colleague and mentor, Dr. Arjun Masurkar, that shows kind of this bidirectional relationship between Alzheimer's disease and anxiety. We can see that there are some things that are direct causality of Alzheimer's disease: synaptic loss, neurodegeneration, network dysfunction in the brain. Um, but then we see anxiety also has some independent factors, such as depression, uh, directly causes sleep dysfunction, changes in hypertension, in your blood pressure, inflammation, cortisol. So this seems like a bit of a vicious cycle between anxiety and Alzheimer's disease. So we don't really know what's the chicken and what's the egg. That's an open question. And depending on who you ask or what research you might read, you may see one or the other. Not really sure. We also don't know where in the brain it originates. So we do have some idea of the brain structures, the hippocampus, um, the distal hippocampus, for example. Um, we don't know where it comes from. We know structures that might be affected, but where it originates is still an open question. Is anxiety causing acceleration in AD progression, or does it simply identify a subgroup that's more at risk? And those are two related but different questions that don't have clear answers just yet. And something that many of us are interested in, myself included, if anxiety is more prevalent in the early stages, and if anxiety is associated with faster progression of AD, if we treat anxiety early on, does that help prevent, slow the progression of Alzheimer's disease? So let's delve into that question. Some research has been done on this, but it raises even more questions. There's not too many therapeutic studies of anxiety and Alzheimer's disease. There's some, but not too many. So this is still kind of an open and fertile research field. So far, what we believe we know is that antidepressants don't do too much for making things better with respect to anxiety and Alzheimer's progression. Um, However, somewhat maybe contradictorily, um, historical use of benzodiazepines, and SSRIs actually decreased the risk of developing MCI, mild cognitive impairment, and Alzheimer's disease in those who had anxiety and this ApoE4 gene that I mentioned earlier that predisposes someone to having Alzheimer's disease. In those patients, use of SSRIs actually decreased the risk of progression. So that's kind of interesting. Um, but one thing to recognize is that all of these therapies have limitations and side effects of their own in the older population. Are they doing more harm than good? Open question. And the biggest open question, of course, is, well, since all of these things are unanswered, it's unclear as of now what mechanism can be used to guide therapy and therapeutic development. That's a big part of my research, and for many of us at the center, we're working on it. That's what I can say about this. All right, so that's a broad overview of blood-based biomarkers and neuropsychiatric symptoms in Alzheimer's disease, specifically anxiety. So now I'd like to bring it together and share with you some recent work that myself and my colleagues published um, about the relationship between anxiety and levels of Alzheimer's disease plasma biomarkers. So just to go back and talk about the significance of this, we know that anxiety is prevalent early on. We know that we need biomarkers that we can use to monitor people early on to build new therapies and new interventions. So it hasn't really been answered. Um, so how do those things connect in people with anxiety and potentially with Alzheimer's disease? So long story short, the question we kind of asked and wanted to answer with this study was, do these Alzheimer's disease plasma biomarker levels differ across stages of Alzheimer's disease or increasing severity as people progress in patients who report neuropsychiatric symptoms? So we looked at two. We looked at anxiety and we looked at depression in this study to see what we might find. So we took about 200 people from here at the center, mostly normal, and about half with mild cognitive impairment and with mild Alzheimer's dementia. And anxiety and depression in our study were measured by study partner report via the Neuropsychiatric Inventory Questionnaire, or NPIQ, which is a common measure for neuropsychiatric symptoms of people with Alzheimer's. And we used this single molecule array, or Simoa technology, to measure various plasma biomarkers, some of which you saw in the table earlier: amyloid beta 40, amyloid beta 42, neurofilament light, and total tau. And we also calculated that amyloid beta 42/40 and tau amyloid beta 42 ratio, similar to the one that was just approved that I showed you a little while ago. So what did we find? What did we see? So here's what we've learned. Here's some data from the paper. We see that anxiety is prominent in the early stages and increases across the spectrum, just like we saw in that earlier graph. So this fits in with other data from other researchers. Higher percentage than general prevalence of anxiety in older adults, and not just limited to worry about memory. And we also see that this correlates with biological measures of Alzheimer's disease, such as the other biomarkers I mentioned earlier: PET, spinal fluid, and plasma. We didn't see this correlation with depression. So you can see here in the little figure to the right, there's definitely a change between anxious and non-anxious people with there's a difference in plasma biomarker levels with anxious and non-anxious people, specifically this tau A beta 42 ratio. And we don't see really any difference at all in people with depression. And here's a larger figure that kind of splits things out by different stages. So we see cognitively normal, CN, mild cognitive impairment, MCI, and of course AD, dementia. And so this Simoa assessment, this single molecule array assessment of these 192 participants at these different stages, showed that the plasma tau A beta 42, so that biomarker ratio specifically, increases across stages with higher levels in anxious versus non-anxious subjects at the AD stage specifically. Okay, so among people with Alzheimer's disease and anxiety, we see this significant difference. This difference was not dependent on whether the person had this ApoE4 gene or not. And once again, to me, this was the most striking thing. This was only seen in anxiety. Depression showed no difference. So that suggests that anxiety with advancing stage was associated with an ApoE4 independent, progressive, and higher level of neurodegeneration, given a certain amount of amyloid doses. What that means is for whatever amount of amyloid beta might be present, people with anxiety have a greater progression. So there is some kind of unique relationship specifically between anxiety and these AD plasma biomarkers, which I thought was pretty neat. We published that recently. All right, so I hope you learned a little today. That's all I have. I just want to leave you with these three last take-home messages, and then hopefully I can answer some of your questions. I hope that today that we've seen the role of biomarkers in monitoring progression of Alzheimer's disease and the continued need for blood-based biomarkers, less invasive, cheaper, and better able to monitor this disease earlier in the progression while there's still time to give one of these disease-modifying drugs. And I hope that we see that there is indeed a close biological relationship between neuropsychiatric symptoms, specifically anxiety, especially at the early stages, a relationship that could help us to better create these interventions at early stages. And finally, Alzheimer's isn't just about memory, but it has whole body implications, has much wider implications beyond just the brain. So it's a very rich field. It's a very interesting disease to look at. And I'm thrilled to be part of it. And I'm thrilled that you guys listened to my talk today. So thank you so much for your attention.